Why is measurement part of science and politics? The most basic and constant standard when measuring a quantity, such as length, weight, and volume, is a unit. Units were created out of the need for measurement. They are the basic standards that indicate length, weight, and volume using a numerical value. In the past, people used parts of their body as units of measurement, instead of rulers we use today. For example, length was measured using fingers or the palm of a hand, and volume was measured by handfuls, holding as much of the object in two hands. However, everyone has different body sizes, which meant that the same object would have different lengths or weights depending on who measured it. As you probably already know by now, ancient Egyptians used the unit cubit to refer to the length from the elbow to the end of the middle finger. In the UK, the unit inch was made based on the width of a thumb, and the unit foot was made using the length from the heel to the end of the big toe. Under the influence of China, Korea and Japan named and used the units of measurement ja or chuk to refer to the length from the thumb to the middle finger of a stretched palm, and 1/10 of ja was called chi or chan. Just as different countries use different languages, such as English, Spanish, French, and Chinese, the units of measurement differed for each country. However, with the development of civilization along with the passage of time, humanity found it inconvenient to use different units. This gave rise to a need for a unified unit system, and the International System of Units came into being. Today, we use the metric system, the standard of measurement around the world. Then, how was the length of a meter determined? When the length of a meter was first determined, it was not the same length it is today. Scholars pondered a lot on how to determine the length of a meter. Eventually, many scholars gathered in Paris upon the proposal of Charles Maurice de Talleyrand from France and decided on the length of a meter through long discussions. Measurement is within the realm of science while being a political issue as well. The metric system, the global standard in the world of measurement, is the product of the French Revolution. Before the Revolution, feudal lords oppressed the peasants, each making their own units and tools of measurement. The French Revolutionary Army believed that the unification of measurement was indeed the way to eliminate the vice and unfairness of the past and realize freedom and equality. The metric system was the gift born out of the French Revolution. The length of a meter that was initially agreed upon was 1/10 millionth of the distance from the equator to the North Pole, passing through Paris. Of course, this distance was not actually physically measured, but it was determined after measuring the distance from Dunkirk, France to Barcelona, Spain, which was then used as a standard to calculate the distance from the equator to the North Pole. A meter is an extremely short distance on the world map, but the process of determining this length was a series of endless hardships and difficulties. France was undergoing a war with Spain, which meant that it took as many as 6 years to finish measuring the distance. Taking place under the political revolution in France, the expedition for measurement was faced with one difficulty after another. At one point, the instruments for measurement that Joseph D'Alembert was transporting was even mistaken for high-performance weapons, coming very close to getting them confiscated by the militia. Delambre also had to go through heavy rain, so heavy that he could only travel 64 kilometers over 4 months. The situation was not much better for Pierre Machain, the leader of the expedition that headed south. The Pyrenees, which Machain had to go through, were full of wolves that attacked people, illegal weapon smugglers, and bandits. Not only that, but as war broke out between France and Spain, the expedition going south got stranded. Even after all the members of the expedition returned, it took another 7 years to accurately calculate the measurements. This was because it was discovered that the leader of the southern expedition, Machain, fabricated results of his meridional survey to increase the credibility of the measurement report. This was the result of Machain's perfectionist tendencies. He later blamed himself so much for the mistake that he suffered from depression and even attempted suicide. The word meter comes from a Greek word for to measure or ruler. The metric system is an international system for units of measurement that uses meter for length, kilogram for mass, and liter for volume as its basic units. In 1799, the length of 1 meter was set as the length of 1/40 millionth of Earth's meridian. However, it has been found recently that a meter is not actually 1/40 millionth of Earth's meridian. Also, a kilogram is not exactly the mass of 1 liter of pure water at 4 degrees Celsius. Thus, the absolute standard of length and mass can only be expressed using the current prototype meter and not by any other methods. Many scientists used Greek and Latin prefixes milli, centi, and kilo to make it easier to measure and read small and large quantities using basic units. Today, with the remarkable development of science, a meter is defined as the distance light travels in 1,299,792,458 seconds in a vacuum. Through a new measurement system that we have come to know as the metric system, France spread the spirit of the French Revolution around the world. The metric system was marching behind the bayonet of the French army. Newly independent countries in Africa began following the metric system in the 1960s as a step to drive out imperialism and become part of the international system. In natural sciences, seconds, the standard of time, and ampere, the standard of electric current, is included in the metric system, in addition to the standard metric units. In some cases, the standards for temperature and illuminance brightness is also included in the metric system. What would happen if units of measurement got mixed up in daily life? Of course, this does not happen often. However, there are cases where confusion of units for airplanes and spacecrafts led to major accidents. On April 15, 1999, a Korean cargo plane crashed near Hongqiao International Airport in China, Shanghai. The Korean Air Flight 6316 destined for Korean International Gimpo Airport crashed 6 minutes after takeoff. Air crash investigators' analysis of the black box showed that the crash was caused by mistaking meter for feet. The pilots of the Korean cargo plane mistook the order from the airport control tower to ascended to an altitude of 900 meters as 900 feet, so they descended instead. A similar tragedy happened in space expeditions. In September 1999, a space probe Mars Climate Orbiter exploded in the orbit of Mars. It was later revealed that the accident occurred because while Lockheed Martin, an American spacecraft manufacturer, made the probe's software to produce data based on the yard-pound system. NASA's Jet Propulsion Laboratory had confused it with the metric system. Because of the miscalculation, the probe entered the orbit at an altitude as much as 100 kilometers lower than it should have. As a result, it exploded friction with the atmosphere of Mars. After this accident, NASA unified all its units to the metric system. Also, on July 22, 1983, a Canadian Boeing 767 had to make an emergency landing because an employee in charge of the plane's refueling confused the kilogram with the pound. With a tank that should have been full only having a quarter of the needed amount, it was inevitable that the plane would run out of gas mid-flight. The pilot maneuvered the plane like a glider with the engine switched off and managed to save the lives of all passengers. Understanding the metric system, the most innovative measurement system, also helps understand history. As was mentioned previously, the metric system was created in the wake of the French Revolution in 1789. At the time, the French society was in a chaotic state. The gap between the noble and the commoners was growing by the day, and the king was only interested in pursuing an extravagant lifestyle with no interest in governing the people. The French citizens could no longer contain their anger and brought about the French Revolution to achieve freedom and equality. The leaders of the French Revolution believed that to build a new society, the system for measuring length, weight, and volume first needed to be reformed. We must not forget that the metric system we take for granted has a tragic history and the sacrifices and efforts of countless people within it. How can the reform of the measurement system be a potential for science? The English word ruler has two meanings. It means a sovereign or a long-scaled tool used to measure length. These two are closely related. They are closely related because it is the sovereign of a country that forces people to use the ruler as the unit of measurement, manages its use, and collects taxes based on the measurements. In ancient Asia, corrupt officials often manipulated the measurement system to exploit the people. There were many corrupt officials that increased the length of the ruler with the official seal or made fake rulers to bully the people. They fabricated the units of measurement to get more grains or fabric as tax than they were supposed to. Fabricating measurement was also done in Western countries. The local merchants, nobles, bureaucrats that were supposed to manage and supervise measurements. Yet, they took the lead in taking other people's possessions, with even the church collaborating with them. The most serious problem was regarding the flour content for making bread. It had long been custom to secretly fake the unit used to weigh the amount of flour and use the leftover flour to make extra cash. As a result, each region had a different measurement system. Around the time of the French Revolution in 1789, there were as many as 250,000 different types units of measurement used in France alone. Given that this was the case of France, with its centralized state, it is not hard to imagine how serious the problem of the measurement system would have been in Germany, which was split into more than 300 federal states. Also, the difference in legal regulations according to the diverging measurement systems used in each region was a problem for those in the transportation business or long-distance traders. The only way they could avoid these regulations was by bribing the custodians, which ultimately increased the shipping expenses. The metric system was born to remove such bad customs that had lasted for thousands of years. Although most people believe the metric system was a work of the French Revolution, it was actually already being prepared under Louis XVI. However, distributing a new metric system was not easy. Because the measurement system was linked to key interests, the local merchants and people affected by the unification of the measurement system were resistant to it. Also, abandoning the measuring system already in place meant cutting ties with the local culture and technologies in many regions, making it impossible to replace the measurement system overnight. It was only with the mobilization of the French government's great power and the fall of the old European system due to the Napoleonic Wars that the metric system could be distributed to various countries. The new metric system started up as a measurement system for stopping corruption and became a pioneer in the wave of globalization. The French-made metric system was rational and consistent, making it easy to spread around the world. However, the US and UK, the original capitalist states, have not been able to move beyond their obsession for the customary units in their daily lives. Nonetheless, the metric system and the international system of units SI has found little difficulty in becoming the global standard. In the basement of the International Bureau of Weights and Measures, there is a weight that is stored in a 3-layered glass container. The mass of the international prototype of the kilogram, a golf ball-sized cylinder made up of a mix of platinum and iridium, is 1.000000 kilograms. However, this weight, which has faithfully executed its duty, disappears into the mists of history. The long passage of time has given it an error of 0.00000001 kilograms. The International Bureau of Weights and Measures made every effort, such as putting the weight in a sealed container, to keep the international prototype of the kilogram contacting air. Regardless, they could not stop the fine changes that occur at the atomic level and had to admit that the reliability of the prototype had been compromised. One 10 millionth of a kilogram is a very small quantity. However, it is by no means a small amount in the fields that deal with life like pharmacy or biotechnology or the fields studying extremely tiny worlds like electronic engineering. To cope with the change, the agenda to redefining kilogram was put into a vote at the General Conference on Weights and Measure in 2018. The conference decided that the kilogram would be defined in a new way. Instead of relying on the prototype of kilogram created by humans, the decision was to define kilogram based on everlasting Planck constant found in nature. In other words, applying electric fields to the opposite side of a scale from the one with a weight on it and measuring how much energy is required to level the scale, it is possible to calculate the mass by converting the unit of the energy. Ancient Greek philosopher Protagoras left a famous quote, "Man is the measure of all things. It is very natural for humans to try to understand the world by using themselves as a standard." Because humans could act as a standard to measure the world, measurements were also made based on standards derived from humans. Cone in Asia and inch in Europe came from the length of a segment of a finger. Cubit in ancient Egypt originated from the length between the elbow and the tip of the finger. Chi or feet were standardized from the length of a foot. However, because every person had a different body size, the measurement based on the human body parts was not precise enough to begin with. Even twins do not have the exact same length of fingers of feet. If the measurement is made based on people with different body sizes, it will cause endless disputes for businesses, slowing down the development of technology and losing consistency in tax policies implemented by the government. Standardization and dissemination of measurement are the most important task in building a civilized nation. With the establishment of Confucian culture in Northeast Asia, various attempts were made to make a unified measurement system. Measurement means assessing the units of length, volume, and weight using rulers, bowls, and scales. Also, the unit of measurement can be also determined by sound. In the Korean ritual music, the note hwangjeong is defined as the sound played by a pipe with volume that can contain 1,200 millets. Because the diameter of the pipe is already determined, its length becomes 1 ja. Ja is the Korean feet that is about 30.0 centimeters and is also known as hwangjeong chiak. Using this unit, it also becomes possible to determine basic units of volume and weight. King Sejong of Joseon dynasty asked his subjects to make the new pipe, hwangjeongwon, and re-established the country's ritual music was not to enjoy the music itself. Rather, it was to establish a system of scientific technology. The idea of measurement borrowing from music may appear sophisticated, but it was not easy to make the idea into a reality. This is because it is for standards based on inconsistent objects like 1,200 of millets to achieve the universality transcending time and space. As humans moved beyond their emotional tendencies and started to think rationally, they realized the measurement based on animals and plants was limited capacities in the study of the truth of nature. They tried to avoid ambiguity from natural features and focused on what was unnatural but precise. This shift in the ways of thinking lay behind the birth of modern science. It may have been natural for the metric system to be established during the French Revolution, which was influenced by the philosophy of Enlightenment. In 1790, a year after the Revolution, the French government decided to create a new measurement based on unchangeable natural objects. The metric system was refined over time to become more precise, decreasing the need to inevitably rely on artifacts like the prototype meter and prototype kilogram. That is, it was not that some of the units used in the metric system were never changed. For example, a precise measurement of the length of the Earth's meridian turned out to be different from its length measured in the past. Also, we found out that the size of Earth changes over a long period of time. Also, moving into the 20th century, quantum mechanics and the theory of relativity discovered Planck constant or speed of light which do not change anywhere in the universe. As such, the metric system is becoming complete as an unchanging unit system. The French Revolution was not the only thing that contributed to the birth of the metric system in France. Among many European countries of the time, France had world-class measurement technology. The many measuring devices that had been previously used were undergoing endless improvements. Such attempts laid a solid foundation for a new measurement system, thereby making it possible to make precise measurements. This was a time when science had started moving beyond a qualitative analysis, discovering the composition and character of a substance, and became capable of accurately calculating the quantity and expressing it with numbers. All this was pioneered by the French Academy of Sciences. The members of the Academy felt that for a country to develop, it must utilize the potential science has, and that reformation of the measurement system was necessary to move in such direction. They unanimously claimed that the new measurement system should not be up to the maker, without criteria or rules, but that it should be made so it is easy to reproduce even if the standard prototype is lost. To them, measurement had to be simple and convenient, while also being rational and universal. This is why the metric system adopted the decimal system. As such, the metric system was born. It went through various changes to become the international system of units today. In 1960, the General Conference on Weights and Measure determined the 7 basic units of the international system of units, such as the meter for length, kilogram for weight, second for time, ampere for current, Kelvin for temperature, mole for quantity of materials, and candela for luminous intensity. Because each of the 7 basic units has a different dimension, one unit cannot replace the other. In modern industrial society, scientific technology has progressed significantly, the speed of which further accelerated through international cooperation. The reason why the international community could cooperate in the field of scientific technology was the measurement standard that can be used anywhere in the world had been made. This universal measurement standard is the International System of Units. The US and the UK, which use the yard-pound system, have also started to put an effort into converting to the metric system. This process will cost a massive amount of money, but it is projected to bring more benefits to both countries in the long run. How does the unification and standardization of measurement affect politics and economics? Sometimes the standard determining a unit changes. In 2018, the General Conference on Weights and Measure decided to change the definitions of the basic units, including mass, electric current, and temperature. This will not make a significant impact on our daily lives. However, it has an important significance for advanced industrial technology including physics. Problems regarding the unification and standardization of measurement had a profound impact on politics and economics regardless of the East and the West, past and present. Not to mention the measurement integrated by Qin Shi Huang, who first unified China, but Yu Jiak, a brass ruler carried around by undercover agents of the king in Joseon, was also a standard to inspect the corruption or extortion of local administration officials. After the French Revolution, the revolutionary government initiated the development of the metric system commonly used around the world today by gathering the best scientists of the time for a national project. To reiterate, a meter was first defined as 1/millionth of the distance between the Arctic and the equator of Earth, while a kilogram was defined as the mass of a liter of the pure water. Then, the prototypes that represent the standards of length and mass and their replicas were produced and distributed. This was how the metric system spread all around the world. Since then, the definition of a meter changed twice. Currently, we determine it based on the speed of light in A. Similarly, a second, the basic unit of time, is no longer defined on the basis of the rotation of Earth, but on the frequency of vibrations of a certain wave generated by cesium atoms. Beginning in May 2019, the definition of a kilogram will be changed to be based on the unchangeable Planck constant from physics. The refinement of the basis for measurement standards follows from the development of precision measurement technology such as atomic clocks. As such, building an accurate standard unit plays a significant role in the development of basic science and advanced industrial technology. Although the history of measurement began in the process of measuring everything in human life, measurement is such an everyday part of our daily lives that few care about how the measurement came about or how it pervaded into our daily lives. From 3000 BCE to the present, the most common measurement standard was a well-balanced human body. Around the 1st century BCE, Vitruvius Pollio, a Roman author, wrote what is known today as the 10 Books on Architecture. In this book, he compiled abundant information across the field of architectural technology, such as architecture, civil engineering, and mechanical engineering. The human face is from the chin to the hair above of the forehead. Its length is 1/10 of the height, the length of a foot is 1/6 of the height, the length of an arm and the width of the chest is 1/4 of the height. As such, the human body has its own harmonious ratios. Even if we were not to go so far as to refer to these words of Leonardo da Vinci about the proportion of the human body, there are universal figures found in the human body. As some specific examples, the circumference of the waist is twice the circumference of the neck and the circumference of the neck is twice the circumference of the wrist. Standardization refers to the creation and use of standards and guidelines to carry out organized rational activities. In today's world, many countries compete with one another and put much effort into universalizing their own units. This competition is so intense to be even called Standardization War. The representative example of the Standardization War is the competition between two internet browsers, Navigator and Explorer. The market share of Navigator, which developed by Netscape in 1995, had been over 80%. However, Microsoft tied Explorer into the sales of Windows and gradually increased its market share. Later, the U.S. Department of Justice tried to impose sanctions on Microsoft for the violation of antitrust law, but Explorer had already become the standard in the global Internet browser market. With the standard of Internet browser, Microsoft defeated its competitor, Netscape, thereby almost completely monopolized the market. Today, it earns an astronomical amount in royalties. Although there is no need to pay for the use of the metric system, the global measurement standard, everyone must pay royalties for the standardization technologies. Whichever company or country trying to create an international standard must carry the burden of investing much time and effort. However, once it becomes the global standard, it is possible to earn royalties from many companies, reaping massive returns amounting to thousands of times the investment costs. In addition, benefits that cannot be converted to numbers, such as wide publicity of the company or the country, are expected. For these reasons, every country and company are throwing themselves into the standardization war. Various measurement tools were made utilizing the metric system, the international standard of measurement. For example, with an ordinary ruler, the length can be measured in millimeters. Micrometers and vernier calipers can accurately measure up to 1/10 of a millimeter. In the past, the role of scales was just to measure weight. However, an electronic scale used at supermarkets has a quite complex structure. It can precisely measure down to the decimal point and calculate the price depending on weight automatically, making it very convenient for small transactions. Today, the measurement does not simply measure the surface of objects, but it can also measure the inside and quality of products like sweetness and freshness. As an example, a device that analyzes ethylene and CO2 generated by fruits in real time and accurately examines their freshness has been developed and will be commercialized shortly. Today, most countries are using the metric system represented by meter and kilogram. The metric system based on the decimal system is widely used in the fields of science. However, the US and UK are still maintaining the yard-pound system of inch and pound. The US has tried to convert to the metric system several times in the past. The first attempt was in 1789 by Thomas Jefferson, an American politician, educator, and philosopher. However, his argument was not supported by the scientific community and ended in vain. Alexander Graham, who invented the telephone in 1906, asserted that the measurement units of length and weight used in the US required unnecessary efforts. This did not mean any changes for the US. In 1968, the U.S. Congress conducted a 3-year study and concluded that adopting the metric system is desirable for national development. Accordingly, it established a 10-year plan but did not mandate the use of the metric system. Entrepreneurs and the general public who have opposed the globalization regarded switching over to the metric system as a kind of defuturing. Besides, according to the public opinion poll, about 45% of Americans disagreed to adopting the metric system. Why are the majority of Americans against the metric system? This is because converting to the metric system has an extremely high cost while its returns are very little. For example, manufacturers have to change the sizes for packing containers and tools. Everyday Americans will have to switch their measuring tapes. In addition, when the weather forecast says the temperature tomorrow will be 20 degrees Celsius, much time is lost calculating it into Fahrenheit. Nevertheless, the metric system is gradually being adopted and used in the US. Drinks are packaged and sold using the unit of liter, car parts are manufactured using of millimeter units, and medicines are packaged in milligrams. Of course, it will take a considerable amount of time for the full conversion to the metric system to take place.